system so much that really we take it for granted. And in order to really understand what the decimal system is, it's actually super helpful to look at other systems that we actually use for computers and other such things. Well, our decimal system, and this you all know, but we indicate the place value, or what we call place value, is the value of the number given its position. Right, so the 2 here doesn't represent that I have two things. Right, this number is 321. This means 20. This means 300. And this means 1. Alright, not because they're different numbers. Of course, if we had 3, it'd be followed by 2 zeros for 300. But that's because we have no 10s and no 1s. What indicates that this is 300 is the position that we give it in the number, which is why we need zeros. If we don't have other digits, we need zeros to actually put this 2 in that tens place. So we have the ones place, the tens place, the hundreds place, and really, you do this in first grade, and I think maybe even in kindergarten, as you learn to count past 9. Well, you notice that these are powers of 10. 1, 10, this is 10 tens, or 100, or 10 squared, or 10 times 10, and then of course we keep going and we have the thousands place, and that's 10 times 10 times 10. And then if we go the other way, instead of multiplying by 10, right, we're going to be dividing by 10 tenths. And so we could go out this way as well, but they're also powers of 10. So as I move from right to left, each place is 10 greater than the one preceding. 1/100th, 1/10th, times 10 is 1, times 10 is 10, times 10 is 100, times 10 is 1,000, etc., etc. And so that's what we mean by place value. That number is, it doesn't just mean 2, it means 2 somethings, and that something is given by its place value. So deci, of course, means 10. So a decimal, we work in decimal. That doesn't, what we mean by decimal is not the decimal point only, but the whole system. It's a base 10 system, number base 10, because it's based on the number 10. And probably because we have 10 fingers, base 10. And so actually we do have other number systems. For example, computers and everything in our digital age is in a system that is called binary or base 2. And just as in decimal we can count from 1 up to 9, but right, we don't have a single digit that means 10. To indicate 10, we don't have another symbol. We take our 1, if it's 110, and we simply put it in a different place. Alright, again, that idea, I'm repeating the idea of place value, but just to mean that, or just to say that we don't have 10 different digits, unless you include 0, or maybe I should say we don't have a symbol that means 10. We use place to indicate 10, pointing to that 1 in the tens place. Right? It's the digit 1 in the tens place. And so also with base 2, we don't have the number 2. In base 2, we use 0 and 1, just as in base 10, we use 0 up through 9. Because in order to indicate our next number, so let's count in base 2, in order to count from 1 to 2, without the number 2, we now put a 1 in the next place to indicate 2. So I have 1, 2, and no 1s. This one's always the 1s place. Or just as over here, right? 1, 2 tens, 3 hundredths. Here, 0 ones and 1 2. So we can add another one to count to 3, right? We can use zeros and ones, so I can add another one. But if I want to add one more to 3, well, I don't have any other digits, so I've got to go out another place. So if I add 1, and this is the 4's place. 5, I can add 1, that's 5. For 6, if I add 1 here, now I'm at 2, I've got to indicate 2, and no 1s, so this is 6. I'm going to scoot over here, just add 1, that's 7. To add another one, well, these are all full. This is almost like 999 in decimal, but in binary, 1 is my biggest digit, so I add another one, and I have to go out another place. This is 8. So if you notice what these places mean, 1, 2, that's a 4, no 2's, no 1's. This is 8, no 4's, no 2's, no 1's. You might notice that these are all powers of 2. 2, 4, 8. Right, the next place over would be 16s. Now let's keep counting just so you see the pattern. For 9, 1, 0, 0, so I'm going to shift over so I avoid crashing into my other chicken scratch up there. That's 9. I add another 1. Okay, that's 10. I add another 1. That's 11. I add another 1. That's 12. And notice how it is the sum of 8 and 4. Right, here's I have 1 8. This is my 8 place, or 2 cubed, 2 squared, 2 to the first power, and then 1. So this is 8 plus 4. This is 12. This is 13. This is 14. This is 15. And then this is 16. So that's binary. That's base 2. And the reason, of course, we use that for computing is 0 is off, 1 is on. And if you're thinking internet, if you have cable or internet that comes by cable, 0 is, right, no signal, and then 1 is a signal, and so you're encoding information basically in on and off, or light and dark. So we use that for zeros and ones. You guys probably weren't here for the big move from cassette tapes to CDs, but that was the big deal. We went from analog to digital, and this is how we encode digitally. So, or if you've seen, well, I was thinking of a movie, but that's the binary system, and it all has to do with place value. So, what is this number in base 2? The subscript 2 means that it's base 2. Well, I'm going to draw an analogy the same way that this was the ones place, tens place, 10 to the second power place in the decimal system. This is the ones place, the twos place, the 2 squared or the 4's place, the 2 cubed or the 8's place, the 2 to the 4th or the 16's place. So if this means I've got 116, the same way over here, that means I have 3 hundredths, 2 tens, and 1 1. Here I've got, if I'm trying to translate this into normal decimal numbers, here this means I've got 116. This means I've got 1 8. I have no 4's, no 2's, and I have 1 1. So the value of this number is 2425. This is the decimal number. I'll put a little subscript 10 for decimal. This is 25 in binary. It's a little problem for you to try out. I'll make a fun number, 101010 in binary. What is that? What is that? As a little hint, remember, this is the ones place, which we haven't talked about 0 power yet, but 2 to the 0 is 1. So this is the 1's place. And this is 2 to the first power. This is the 2's place. This is 2 squared, or the 4's place. Alright, give that a try.